You are highly welcome to this comprehensive revision session for the SS2 Chemistry Alternative to Practical ATP examination for SFC students. In this video, we will go through essential practical-based questions, guiding you step by step in calculations, observations, and interpretations. The question 1, this will be based on acid-base titration. In this experiment, we have solution A, which is 0.200 moles per dm cube of HCl, and solution B, which is made by dissolving 12.3 grams of impure Na2CO3 in a 500 centimeters cube of solution. The reaction equation is shown here. A. You will be completing the titration table here. Something like this. The initial readings and final readings are given. We subtract the initial from the final to get the volume of acid used for each trial. Let's complete the table. I. Get the average volume used. Using the concordant titers, we take the average. We take only the concordant titers. Average volume of a concordant, 24.40 plus 24.30, divided by 2. Equals 24.35 cm cube. Mind you, in West African the concordant titer can take range of 0.2. Here I used only 0.1 on purpose. 2. Relative molecular mass of Na2CO3 using atomic masses. 2 times 23 for sodium, plus 1 times 12 from carbon plus 3 times 16 for oxygen, equals 46 plus 12 plus 48 is equal to 106 gram per mole. 3. Concentration of solution B in mole per dm cube. Moles equals mass divided by molar mass. Equals 12.3 grams were dissolved in 500 centimeters cube. Mass concentration of impure Na2CO3 equals 12.3 grams divided by 0.500 equals 24.6 gram per dm cube. 4. Concentration of solution B in mole per dm cube using the titration formula. CAVA over CBVB equals NA over NBCB equals Ca times VA times NB over VBNA. Solving for CB equal to 0.2 times 24.35 times 2 over 25 times 1. CB equals 0.097 moles per dm cube. V. Calculating the percentage purity. If you find the mass concentration of this 0.097 moles per dm cube, which is 0.097 times 106 the molar mass, you have 10.3 g per dm cube, divided by the previous value which is 24.6 gram per dm cube. Then multiply it by 100, you have 42.3%. Recall mass concentration of the pure over mass concentration of the impure salt times 100 is the percentage purity. Question 2 is based on salt analysis. Recall the action of the sodium hydroxide song. 1. Sample E, aqueous, plus sodium hydroxide, aqueous, in drops. The observation is a white precipitate form. The inference is Ca2 plus, Mg2 plus, Al3 plus, Zn2 plus, Pb2 plus ions are present. If in excess, the observation, the white precipitate dissolves. The inference is Al3 plus, Zn2 plus, Pb2 plus ions are present. But if in the observation is the white precipitate insoluble, then the inference is Ca2 plus, Mg2 plus ions are present. If the mixture was warmed, and the gas being released is capable of turning damp red litmus paper blue, it is ammonia gas NH3, and ion presence is ammonium ion NH4 plus. If ammonium hydroxide was used instead of sodium hydroxide, it is only zinc ions will be soluble in excess in copper-2 ions. Copper-2 ions will be deep blue solution. No reaction with calcium ions, but the same as sodium hydroxide. Note lead in calcium white precipitation is chalky or said powder-like. Get that. The others are gelatinous. But no action of ammonium hydroxide on calcium ion. This means no chalky white precipitate. To test for anion. 3. Let the sample be aqueous plus Basil2 aqueous, then HNO3 aqueous. If the observation is a white precipitate and remains insoluble after adding trioxonitrate 5 acid. Wait. Have you subscribed? Have you shared the link? What about notification bell? We are 900, let's make it 1000. Then SO4 2- ions are presence. If there were effervescent with colorless odorless gas, it is CO2 gas that came out, the anion is CO3 2-. If there were effervescence with colorless gas with a pungent smell, it is SO2 gas that came out, the anion is SO3 2-. But question 3 is all about graphs of rate of reaction. The y-axis represents mass loss, gram, and the x-axis represents time, seconds. You are to plot the points carefully using a pencil and draw a smooth curve. You should be able to answer the following questions. When does the reaction stop? You have to look from the table or the graph to see when the mass remains constant, meaning no more gas is being produced. Learn to calculate mean or average rate of reaction. Instantaneous rate of reactions is necessary. You might be given a given period in the graph to calculate the rate of reaction. Formula: rate equals change in mass over change in time. Rate of reaction for the whole reaction. Rate equals total mass lost over total time taken. An exposition for you. Look at this graph. This curve is when temperature is increased. This is when the temperature is reduced. Hope you got that? This is very important. You might be asked to make a sketch on the same graph if the temperature is increased. Check the graph properly. Let me say that this brings us to the end of this ATP revision session. We covered titration, salt analysis, and reaction rates, ensuring you are fully prepared for your examination. Remember, practice calculations, make use of your calculator. Memorize qualitative test results. Make use of the songs. Action of sodium hydroxide. Be confident in plotting graphs. Good luck!